Yeah,
Yes.
but tell me what is one security problem here? What is one? Just by looking at this, tell me what is the security problem here?
It is showing password also.
Right? So what happens in DB? So for example, you all have account in Instagram, Facebook, everywhere. Yeah. So you will use password by default. Yeah, everywhere. Now, what happens is that when storing the password in the database, when storing the password in database, right? Generally, we should ensure that we should not put the plain text as a password in the database. Now, if we put a plain text as a password, as in whatever is the password that you entered, if we put the same password in the DB, now what happens? Anybody who is working in particular Instagram or Facebook company, okay, they can look at what is your password, right? And they can log into your account also because they know your password. So generally, even the employees of the Facebook should not be aware of your password, right? They should not know what is your password at all, right? So we need to get something in, we need to get something in between where I can convert that plain text into some random sequence of alphanumeric values, random sequence of alphanumeric values, where nobody will be able to understand what is the actual password. Nobody should be able to understand what is the actual password. So nobody should understand. So this should not have the text field, right? The actual plain text. This should contain some random number. This should contain some random random alphanumeric values. Okay, for that, so we should basically use a technique where nobody will be able to understand what is stored and nobody should be able to decrypt from what it is. Okay, now in order to keep our password encrypted, in order to keep our password encrypted, so we will need certain function, certain library which will help us do that, right? Right, bycrypt is a Python uh, package where we can use to encrypt the passwords, to encrypt the password. This is a particular package which we can use to encrypt the passwords, right? So if you can just know bycrypt as a library. So it is a modern password hashing software, right? It is a password hashing. So hash is always one value. So for example, here, this is your password, my password too. This is your actual text. But what does that hash function do? It converts that into some random alphanumeric with the special characters, right? Value where it is very much different from your actual password. So by looking at that, nobody will even know what is the password. What is the password? Okay, let's see, right? Let us try to store that. Let us try to store that information. One moment, where is it? Let me just close this. All right. Now let me do one thing. Let me just, okay, fine. Let me just keep it as is. Now the bycrypt, when it generates a hash password, right? It might not be 12 characters. Now if you see, right, so what is the SQL schema SQL? What did we do? We say 12 characters, but when we generate a hash, it might not be 12 characters. It will go beyond 12 characters. So let us just check what is the default character length, so that we'll use the same length. Right. It is a 72 character limit, right? It is limit is a 72 characters. So while creating, we should create our varchar with 72 character as a length, 72 character as a length. Let me just get it from the official website. So first we'll have to install. We'll have to install. So let me just stop the server. Okay. Pip install decrypt, and let's wait it down. So yeah, it is installed. Okay, it is installed. Now let's go to the Python console. Yeah, let's go to the Python console. Okay, let me just import decrypt. So we just installed, so it would work, right? Now the password that I want to encrypt is my default, my text password is test at 123. Okay, this is my test password. Yeah. Now I want to encrypt into or hash it, right? Encrypt, right? Hash it somehow and see if I can actually manipulate the data into some string that I cannot understand, right? So I need something called salt. We generally call it as like, to do the hashing. We need this. So this is also provided by the Bcrypt itself. Generate salt, right? Now I know what is my salt. It is basically some random string. Okay. Okay. So I'll be using that. So my hash password is equal to dot hash password. I have a function hash password. I have a function and I'm going to pass my password, which is test at 123, and I'm going to pass that salt that I just created. Now, okay, encoded, right? Where is my password? Dot. So I have to use encode and I have to encode it to a format called UTF-8. It has more. We discussed about UTF-8, right? So ASCII versus UTF-8 in one of the classes earlier, we did discuss. So I'm just converting it to the UTF-8 format because my hashing works only on the UTF-8. Right now I should be able to hash password. Now if I just see hash password, right, it has some. Can you, is it, what is your password actually? This is your password, right?
Yes, sir.
But when I hashed it, your password actually became this. Right now, this is what I will be storing in my DB. This is what I'll be storing in my DB so that nobody understands this. Like, they cannot figure out, okay, what is the password? They cannot know what is the password. Hashing is always one way. Once it is hashed, it is hashed. Right now, if I want to know, is it a valid password or not? So you would enter the password again. So what I will do, right? So I have to check if this is equal or not. So this is the previous one that at the time of registration, this is the password that you have given to me. And now also you will try to enter the same thing. What I will do, I will try to hash the password again. Now, whatever. So let us say you entered. This is the password again. You enter test at 123. Now I want to check if these two are equal. The one that I had actually entered and now that I have. Right now, hash password equal to hash password entered. What happened? Did you mean what is the value that I did enter? Entred. Oh, hash is wrong. So this basically says true, which means it is valid. Hash password and hash underscore pw underscore entered. So they both are same. That is how I'm going to validate. Hashing is always one way. Hashing is always one way, right? Either you can do this way, or you can it also has a built-in function, right? It also has a built-in function, which is decrypt dot check password, right? What is my password, right? Whatever that at the time of entering I have given. So it is test at 123. I have to encode every time I have to deal with this. 8. And what was this password that was created earlier? Hash PW. Now this will return true if they are valid. Okay. If I say test 124, right, this is invalid. So it will say false. Okay. So this is the function. This is the library that we will be using. This is the library that we will be using to generate the hashed passwords. But before that, what is the thing that I have to do? Len of hash underscore pw, it is 60. So the maximum is 72 characters. Now this I will change it to 72 characters. 72 characters. So we should not store plain passwords. We should not store plain passwords in the DB. Okay, let me go back. Let me drop it. Right. And let me recreate by converting this to a 72 character length. Let me recreate the table. Done. We recreated the table. Now we'll add this functionality into our code. What is the library that we should be using? Decrypt, right? Done. So we have converted. So whatever is the password, right? I am going to encode it. I'm going to encode it to which format? UTF-8 format. Now, before that, I have to convert this. But before that also, what are the things that I will need? Oh, yes, I have a B group, but I want a salt as well for this application. I want the salt to create the password, right? Bcrypt dot generate salt. That's it, right? This would generated a particular salt, which I will be using to generate the password, which I'll be using to generate the password, right? So here, bcrypt, I'm going to reassign password hash is equal to bcrypt dot hash password and the password that is entered. Now this is what I'll be using to store in the DB. This hashed password is what I'll be using to store in the database. Done. Now let us go back to the HTML. Right, let us go back to the browser. Now let us reload and let us try to create. Okay, I have to start my server. I did stop the server right earlier. Okay, let me reload. Yes, I have my server now. .com and a password. I'm going to write something, right? Do you know what is the password that I entered? You don't. And I just say click submit. This is basically okay. So I did not provide. Hold on a second. I did not provide the hash password, and I have to provide the salt that I created at globally. Okay, let me just reload this. Let me try submitting it again. Okay, string data, right truncation, PG errors, value too long for the type character 72. So looks like it is longer than the 72 characters. Who is that? This is not mentioned anywhere in the documentation. Let me just find the right length. They're saying 72 characters, but it seems like it is longer than the 72 characters. The 72 bytes. It seems like it's longer than the 72 bytes. Let me drop this. It to 100 characters. See if I will be, I don't know how come it is longer than 72 characters. I don't understand, but yeah, let us save it and let me recreate this. Okay. So be straight and value too long for type character varying. Let me just print the value first. I don't know what is the value that it is trying to. Password hash. Let me just see. Let me reload this. Let's go to the browser. It is saying yes, it is too long, but what is that long? This, how many characters do we have here? Let me try reloading this again. Now I have converted to a string type. Okay, seems it worked now. So for some reason it was not taking, so I did convert it to a string type. Now let us see, does that actually show the raw password? Okay, is it the password that you entered?
Yes, sir. It is encrypted.
Right, it is encrypted. Now you don't know. Earlier it was showing test at 123. Now it is showing encrypted password. Encrypted password. Okay, so I think str is also not the right thing. So let me also encode this to. Okay, let me just try it again. Okay, so it did work. Now let me just go back and rerun it. Okay, so we have to say decode while storing, not string, right? That way it stores properly. So this is the text that this is the text. Now this is very much against the password, right? It is not the raw password at all, right? Let me just drop it and recreate with the same 72 characters because that is the max length as mentioned by the bcrypt. Now let us run this create table. Now let's go back here. Right. Okay, it got created and it got redirected to the page as well. So let us go back and see where did we create? Did we get the record properly? Yes, srikanth@gmail.com, and this is my encrypted password, which means you don't know what is my password now. Not as an application owner, though you have access to the DB, you will not be able to guess or know user password. Guess or know user password. Clear? So you should never save the password in the plain text that is given by you, right? We should always encrypt it. We should hash it and store. And for hashing purposes, what is the library that we are using? What is the package? Bcrypt. Bcrypt is the package that we used. And in order to validate right? In order to validate, right? We'll be using the bcrypt itself. Instead of hash password, we'll use check password function. We'll use check password function. All right. Okay, let's do one thing for check password and the login functionality, right? We'll sync tomorrow. But yeah, so for today, remember we have learned something new, which is bcrypt. Okay, an external package that we have installed. What are the steps to hash the password? You have to install bcrypt. After that, you have to import bcrypt and generate a salt using the bcrypt function itself, gensalt function, right? After that, it has a function called hash password where you have to pass the password that you want to save and hash and also the salt. And that's it. So once you do that, this will basically, this function will hash the password where from the normal text to it is a hashed password, meaning it is a one way. So nobody will be able to decrypt in future. Nobody will be able to decrypt it, right? That is all the security purpose, because you don't want people to know your password, right? Though it be your Gmail account password, even the employee, Google employee who is working on a Gmail platform will not be able to look at your password, will not be able to look at your password or understand what is your password. So nobody will be able to log into your account except you, right? So that is a very, very fundamental of a security, that even the employees of a Facebook company should not know your password. So it is all encrypted, it is all hashed, that nobody will understand. So even if you are writing your application going further, you should ensure that the passwords are hashed properly. Clear?